In this video, I want to talk about naming your class base. So a few weeks ago, I wrote a tweet that says, controversial opinion, base is not a good name for any class in your code, unless your software is for planning big buildings full of generals. So my friend Prabin wrote back and said, well, what about a base request for external APIs? We had a bit of a discussion about this, and Prabin agreed to send in some example code to demonstrate what he meant. So here we have some code that defines a wrapper for the Stripe API. It consists of a base class, which tells us how to make a post request, a get request, a patch request, and a delete request, and also some extra methods for configuring request headers. Then there's a customer class, which tells us which endpoints we want to talk to load and create and to fetch various customers on the Stripe API. And also a subscription class, which tells us how to create, fetch, and destroy subscription resources on the Stripe API. So to put it more simply, what we have here is a base class, a customer class, which inherits from base class, and a subscription class, which also inherits from base class. But it's the base class that I want to look at today. You see, this is an example of what we call an abstract base class. And I think that when people are naming these classes, they often put a bit too much emphasis on the base part and not enough on the abstract part. By calling a class base, instead of naming it by the abstraction it defines, the code becomes less descriptive. And this might seem like a bit of an unusual example, but imagine we were writing code that describes something real and tangible and natural like animals. Imagine we had a dog class and it inherits from the canine class, and the canine class inherits from the mammal class, and the mammal class inherits from the animal class. In other words, a dog is a canine is a mammal, and a mammal is an animal. This makes sense to me, but if we were to swap out animal for base, and then say a dog is a canine is a mammal, and a mammal is a base, then suddenly it feels off. We're not describing this level of abstraction with a word that properly describes it anymore. Instead, we're using a vague, general, conventional word. I think that's the same feeling I get when I see code structured like this, when I see that a customer is a base and a subscription is a base. Really, I think customer and subscription can both be thought of as the same type of thing. And the thing that they have in common is that they are both defining specific clients for an API. So really, they're both API clients, and so I think this code can be greatly improved by simply renaming the class to something like API client. But there's something else that I noticed about the code that I wanted to describe before we actually go and start changing the code itself. Let's focus on the customer and API client relationship for a second. See, when I look at the code, I saw that the API client itself, it handles things like configuring the connection to the server, and it describes some general methods for each HTTP verb. Whereas the customer class defines specific CRUD methods for a specific API resource. So it's not totally clear to me that customer actually is a more specific kind of API client. It's really just the case that the API client is providing some utility behavior that the customer class relies on. And so when I see a pattern like that, I often think to myself, well, what if we were to restructure this? So instead of saying customer is an API client, why don't we say customer has an API client? Let's have a look at how we might do that in the code. So this is the code that Prabin sent over. And I'm going to start by just running rake just to demonstrate that all of the tests pass and this code works. as we've just discussed, I think we should rename this class to something more descriptive. So let's go with API client for now. I think that's already a lot more descriptive. But we were also saying that the inheritance relationship between customer and subscription and API client might not be the best way to structure this code. So how might we do things differently? Well, let's have a look at the customer class. What if we were to say, instead of the customer is an API client, why don't we say that it has an API client? And I'm going to keep the inheritance relationship there for now, just while we do this refactoring. So I'll run the tests, and we're still passing. So I think what we're going to do then is, instead of passing these methods like get and post and patch and delete, instead of passing them up the inheritance chain to the superclass, let's delegate those to our API client class instead. I'll run the tests here for now. Everything's still passing. The patch method here at the moment is calling super because there's also a method named patch in the superclass, but I'm going to rename this to patch and then delegate it like we have with the others. And it's the same with delete. So there's also another one, search. And if we rerun the tests, everything's still passing. Hopefully we can just remove the parent class now and this will just work. So it's failed, but it looks like it's failed because we are relying on a constant that was defined in the base class that's no longer available to the customer class. So let's remove that from here for now. And in the base class, why don't we bring that in here? So let's start by defining a private method called URL for path and pass in a path. And the purpose of this method is just to take a relative path, to add the base URL to it, and return a full URL for that resource. So let's say URI join base URL path. And then I want to change all of the arguments here to be paths. URL for path, and yeah, right. And again, the reason for this is that this base URL constant is no longer available to the customer. And so I think our code is a lot neater if we just delegate that behavior completely to the API client class. Let's run this test now and see if they pass. And it looks like we're getting some error based on this being a URI object and not a string. So we can cast that again as a string for now. Cool, our tests are all passing again. Let's do the same thing for the subscription class. So we started off by giving it an API client as a dependency. We say API client equals API client. We want to make that available. And then we want to delegate all of these HTTP request methods to our API client. That's all passing. Let's see if we can safely remove that superclass now. We've got another failure somewhere. Yep, so we didn't remove the reference to the base class up here. The base URL, sorry. And that works. Cool. So one of the reasons I like preferring composition over inheritance like this is that it often makes it easier to write unit tests for my code. And part of the reason for that is that the code has better separation of concerns and each part of the code is doing less. So I can often mock and stub the behavior of the dependencies rather than assuming that those behaviors are built into the class that I'm testing. Let me show you what I mean. If we look at the customer class and the create method, what's this create method really doing? Well, it's forwarding the post method onto its API client along with the request path, and it's also forwarding the attributes hash. And then we want to make sure that it's returning a JSON or a hash or an array that represents the response coming back. When I was writing the tests for this code previously, I would have to stub the HTTP request in every one of the tests because the code was attempting to make an HTTP request on each test, and that's not really what we want. But with this new composition-based approach, we can actually just mock out the calls themselves, and so we don't have to do any of this request stubbing. Let me show you how I'd approach doing that. We can just delete the stubbed request altogether, and what we're going to be doing is we're going to be passing in an API client rather than using the default API client that's set as the default dependency here. We're going to be saying API client equals, and we'll just create a stub for this. So, and then we want to pass in our stub as the API client for this particular object we're testing. Then, because the behavior that we're really testing is, does this class forward the post method onto the API client, we can just say that API client should expect post with the request path, which was v1 customers, and the attributes, and that it returns just an empty JSON object should be fine. We can remove these, and again, all we really care about is that we're getting back a hash in the response. So let's run this test and see if it works. Great. That test is passing, and we no longer have to stub out the requests. Instead, we can just stub the simple method calls to our API client. Personally, I think this is simpler and an easier way to write tests. I won't go through every other test example in this code, not on camera, but I will update the code and push it up to GitHub afterwards if anybody would like to take a look at it. But what do you think? Have I convinced you that base is a terrible name for any class? And what do you think of the composition over inheritance idea? Please let me know what you think in the comments section below, or fire me a tweet on Twitter/X. Thanks for watching.